Okay, in this lesson we're going to figure out how to find the sum of the interior angles of any polygon. So we're going to take a look at that. So we already know the sum of the interior angles of a triangle. We know that's 180 degrees. And yesterday we looked at a quadrilateral, and we know the sum of the interior angles of a quadrilateral is 360 degrees. So we're going to start to fill in some of the information in this table here. So when there are three sides, the number of triangles we know is 1, and we know 180 degrees is the sum of the interior angles. When there are four sides, remember we looked at this yesterday, I can draw from this vertex, I can draw one diagonal. There are two triangles, and two triangles means 360 degrees. So, continuing on with that pattern, if I draw the diagonals, there's 1, there's 2. For a pentagon, 5 sides, I see 3 triangles there. And if I take 180 times 3, I'm getting 540 degrees. So we could do that for any figure, and we're not going to do that for all these, but we'll do one more. So I'm going to draw in the diagonals. I can see that there are 3 diagonals. There are 4 triangles. So I'm going to take 4 times 180, and I get 720. Okay, so let's generalize a little bit here. If we have n sides, how many triangles would there be? Well, when there were 3 sides, there was 1 triangle. When there were 4 sides, there was 2. When there were 5 sides, there were 3 triangles. When there were 6 sides, there were 4. As you can see there's a pattern. Every time there are 2 less sides than there are there's 2 less triangles than there are sides. So I'm going to take the number of sides, which we're calling n, and we're going to subtract 2. Now, the sum of the measures of the interior angles. Well, back to the triangle. There was only one triangle, which was represented by n minus 2, and then we have to take that times 180 because we know every triangle is 180 degrees. So for the quadrilateral, there were 2 triangles. 2 times 180 is 360 degrees. So every time after we subtract 2 from the total number of sides, we multiply that by 180. In other words, n minus 2 has to be multiplied by 180 degrees to give us the sum of the measures of the interior angles of the polygon. So there's our formula. The sum of the interior angles of any polygon is n minus 2 times 180 degrees, where n, of course, is the number of sides. Okay? So we're going to use that to figure out this problem here. So let's take a look. So I see that I have 1, 2, 3, 4, 5 sides. So 5 minus 2 is 3. 180 times 3, oopsie, 180 times 3 is 540 degrees. So what we'll do now, that's the sum of all of the interior angles. So we know that the total will be 540. So we're going to add up all these angles. So we'll write an equation here. We have 108 plus 5x plus 8 plus 4x plus 28 plus 6x minus 12 plus 108, and that should equal 540 degrees. So let's see if we can combine our like terms. So we have a 5x, we have a 4x, we have a 6x. So 6 plus 4 is 10. 10 plus 5, we have 15x. And now I'm going to add the others here in my calculator. So I'm going to add 108 plus another 108 plus 8 plus 28 minus 12, and that's going to give us 240. So that equals 540. So I'm going to subtract 240 from each side. I'm getting 15x equals 300. And I'm going to divide 300 by 15, both sides by 15. And I'm getting that x equals 20. So it says solve for x and then find the angle measures. Well, that's 20 degrees. So I'm going to go ahead and substitute 20 in here for each angle. So 5 times 20 plus, that's 20, plus 8. 5 times 20 is 100. Plus 8 is 108. Substituting in 20 here, 4 times 20 plus 28. Well, that's 80 plus 28. That's 108. Okay, it's looking like this might be, this might have all the same angle measures. Clearly the sides don't look like they're all congruent, so I don't know if it's regular or not, but look, we'll plug in 20 one more time. So 6 times 20 minus 12, that's 120 minus 12, again, that is 108. So this particular polygon, or pentagon specifically, all the angles have measure 108 degrees. Okay, so if I gave you the sum of the interior angles of a polygon and I ask you to find the number of sides the figure has, how would we go about doing that? Okay, so let's take a look. Well, let's think about, let's see here. Let's think about our formula. So we know that the sum formula is n minus 2 times 180 degrees. So if we're being told that that sum is 720, we'll just set that equation equal to 720 degrees, and we'll solve for n. So let's first, we need to get 180 out of there, so we'll divide both sides by 180. So I need to figure out here what 720 divided by 180 is, and that's 4. That's not my answer though. That's not the number of sides because that's equal to n minus 2. So I have to add 2 and get 6. So how many sides are in this polygon? 6 sides. Okay, so let's take a look at a couple more here. So 1440, I'm going to set 1440 equal to n minus 2 times 180. And I'm going to divide by 180 on both sides. So I'm doing 1440 divided by 180, and I'm getting 8 equals n minus 2, which means n is equal to 10. Okay, so you should probably try this one, but I'll go ahead and do it. You can pause the video and try it. So 900 is equal to n minus 2 times 180. So I'm going to divide 900 by 180, dividing both sides by 180. And I'm getting 5. That's n minus 2, which means 7 is n. So there are 7 sides. Okay. Next. So we already know what a regular polygon is. We know that it's when all angles and sides are congruent. And we already know what a convex polygon is. When all the diagonals are inside the polygon. So we already know what they look like. Here's some examples of regular convex polygons. Okay. So if we found the sum of the interior angles of an n-gon, we have that equation. How can we use the equation to find the number of degrees in one interior angle if it's a regular n-gon? Regular, again, meaning all the angles have the same measure and all the sides have the same length. So if we already have the sum, and that's this, but all of the angles have the same measure, then we can just divide that by n, because that's the same, n is the number of sides, which is the number of angles, and that'll give us one interior angle if it's a regular n-gon. Okay, so let's take a look at that. Oops. So there's our formula. So it says the measure of one angle of a regular n-gon is equal to n minus 2 times 1e. So that's our sum formula, and just divide that then by n, which is the number of sides and the number of angles. So find the measure of one angle in a regular pentagon. So we know that's 5 sides. So we're going to take 5, and we're going to subtract 2, and we're going to multiply that by 180. That'll give us the sum of all the interior angles, and then we'll divide that by 5 because there are 5 angles. So that's 3 times 180, and we'll divide that by 5. So 3 times 180 we already got before is 540, and we're going to divide 540 by 5, and that'll give us the measure of one interior angle of that regular pentagon. So 540 divided by 5 is 108. So the measure of one angle is 108 degrees. Next, this time it's still regular, but it's a hexagon. So we'll subtract 6 minus 2, and we'll multiply that by 180. Again, that'll give us the sum of the interior angles, and then we'll divide that by 6. So that's 4 times 180, and we'll divide that by 6. So 4 times 180, 4 times 180 is 720. And when I divide 720 by 6, I'm getting 120. So the measure of one angle is 120 degrees. That's a 0. Okay. So exterior angles. The sum of the exterior angles of an n-gon. Okay. Well, we'll try that. So we'll just look at this first figure here, this one, that one. So what we'll do is, you notice here we have all these interior angles filled in. Well, we can figure out the exterior as well. So I'm going to start with this 79-degree interior. I see that the exterior is the linear pair with 79. So I'm going to do 180 minus 79, and that'll give me 101. And that's going to be that exterior right there. I'm going to do that all the way around this polygon. So I'm going to subtract 180 minus 82, and that'll get me 98, which is this angle here. Moving right along, 180 minus 121 will give me this one here, 59. Next, 180 minus 78, and that'll get me 102. And now I have all those exterior angles. That's a 102. So if I add those, 102 plus 101 plus 98 plus 59, I'm getting 360 degrees. Okay. Now, you might be thinking, well, 360 degrees was the sum of the interior angles too, so maybe for a quadrilateral, so maybe the exterior angles is just the same as whatever we got for the interior. Well, not actually the case, even though it might look like it at this point. If we were to continue with these other figures, and we're not going to take time to do that today, but if we were to continue on, we would go about this next one the same way. If I was looking at this one, I would get the exterior here, 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 here. So this one is a pentagon, so the interior angles aren't 360 anymore. That's 540. Well, the exterior angles, the sum of the exterior angles is still going to be 360 degrees. It's not going to be 540 like the interiors are. And if I looked at this next one and I found all the exterior angles and I added them, I would still get 360 degrees. And same thing with this other one. Any n-gon, the sum of the exterior angles will always equal 360 degrees. Always. Okay, so we don't have a formula or anything. You just have to remember that any polygon, the sum of its exterior angles will always be 360 degrees. Okay, so if I'm trying to do a problem like this one, and I'm supposed to solve for x, well, I'm just going to add up all these exterior angles, and I'm only missing one, so I'll just subtract that then from 360 because we know that the sum of the exterior angles is 360. So 66 plus 74 plus 57 plus 56, I'm just adding those in the calculator, 66 plus 74 plus 57 plus 56 is equal to 253 degrees. So 253 degrees plus x should equal 360 degrees. So I'm going to subtract 253 from 360, and that gives me x is 107 degrees. Okay, so now we're going to find the measure of one exterior angle of a regular n-gon. Okay, so finding the measure of one exterior angle of a regular n-gon. So we know the sum of the exterior angles 360 degrees. So if I'm finding the measure of one exterior angle of a regular pentagon, well, I know the sum of the exterior is 360. So I'm going to just divide 360 by 5, and 360 divided by 5 is 72. So the measure of one exterior angle is 72 degrees. So we can do the same thing here. We know the sum of any polygon's exterior angles is 360. So we're going to divide that by 6, and that'll give us 60 degrees for each exterior angle. Go ahead and try these problems in your packet to get some more practice.